Hello and good morning, everyone, and welcome to another one of our aquatic control engineering webinars. This particular webinar, we're going to be focusing on fish monitoring solutions. So ACE have got a couple of monitoring, in particular trapping solutions, which I'll quickly take you through. And then we work very closely in partnership with VAKI, who produce the River Watcher and also the Elver Watcher products, which we have on the UK market. I'd quickly like to let you know what ACE stands for and who we are. We're a company that comes originally from flood defence background. We've built some of the biggest flood defence assets that there are in the UK. For example, the left image is Morpeth up in Newcastle. But with flood defence, we've also, we very much look carefully at fish passage and fish migration and providing solutions from bypassing pumping stations, pumping fish through pumping stations, fish ladders, eel passes, all those kind of things. And holistically, as a company, what we try and do is make sure that we protect people, property, and the biodiversity using innovative and sustainable solutions. With the fish passage, how we really got into it was, it started with fish-friendly flap valves, and from there, the Environment Agency and some rivers trusts worked closely with us to produce eel passage solutions. This is one of the very early eel passes that we delivered in 2011. And you can see that our design has developed somewhat since then. But of course, as people are installing eel passage and fish passage products, there's more and more question about how do we monitor. So this is one example from UK's largest promotion, St. John's. It's got 100 cubic meters per second capacity. And you can see that immediately from these photos, people are trying to find ways of counting the elvers on this particular site. On this site, they eventually managed to monitor the elvers. They were getting such high quantities that they were actually weighing them at the end of every day rather than counting them. But you can see from April 2014 that over 50,000 elvers were monitored using the pass. We therefore started to look at some different options for monitoring. This is one example for Bristol Water with the Environment Agency, which is a trapping box. So the elvers come up the system, they end up going through, entering the trapping box. You can see there's very fine net in there, so it allows the water to continue passing through, but keeps the elvers there. And then on a daily or maybe bi-daily basis, somebody can go down and monitor them. And this particular site was also set up, you can see with the benching around the trap, so that kids from local schools could come and have a look, peer inside and get involved and get their hands on the nature. The traps developed a bit further. This one was with one of the early traps that we did with the Galway Rivers Trust up in Scotland. And you can see here as well, it was a hydro dam project. And what they were trying to ascertain is, do we need an elver pass at this location to get the elvers over the dam? Or are there actually no elvers here and we're wasting our time building an elver pass? So the first things first is you've got to know, are there elvers present? So we constructed this pass. It's basically an eel pass, but it stops at a dead end. There's a net on the inside of it, and you can see the blue hose that's running in the background. That is essentially a siphon. So it's getting the water from higher up, forcing it through the hose into the pass, creating the attraction flow and allowing the elvers to get in. They were really pleased with this concept, so they ordered another one. We did have some questions about vulnerability to theft and that kind of thing. So we changed material to what we know. We make the eel passes, a lot of them out now, which is HDPE. You can see here the three-dimensional model of the elver trap. You can see the net that we put on the inside, the holes that we have to allow passage. And this, of course, allows the elvers to drop into the net, and then they can be examined, monitored, weighed, counted, whatever. So you can also, the Rivers Trust wanted to be able to move this from location to location, so they could see at what location there were elvers and at what location there weren't, to help them decide, yes, we'll have an eel pass here, but actually there's not many elvers here, so this particular site, we don't need them. Now, we move on to the Environment Agency, who had a bit more of a technical need. This is a eel pass at East Mills in the east of the country. And you can see here that we've put on, and we've worked with VAKI to develop an Elva counter. So the beautiful thing about the Elva counter is it's automated. So it's actually using smolt technology from the fish farming industries, where they grade different smolts by different sizes using optical lenses. And this is being done exactly the same with the Elvas. They go up the eel pass, they reach this highest crest level, and then they slide through the Elva counter over the top of that white board, so they're visible to the camera. And then the camera can pick out, you can see from the small image in the bottom left, it can pick out rough sizing and also automated counting. All of this can then be fed to the internet into a live portal, and you can watch the data live. And the portal, the online portal, can also produce automated reports. But before I talk too much about this and the other VAKIs, I'm going to pass you over to Magnus, who's currently over in Iceland at VAKI, and he's going to be taking over from here for a bit to tell you more about the VAKI.
Yeah, thank you, Martin. Thanks for having me on this webinar. Good morning, everybody. I'm going to talk a little bit about our products that we have for fish monitoring and the challenges that we face, and I'll show you some examples of what we can do with the equipment. Let me try to share my screen here real quick. See if this works. And
yeah, it's the display settings, Magnus. Yeah.
There it is, that one.
And then switch. There you go. Beautiful.
There you see my presentation starting. See this picture. If you just for a moment take a look at how the fisherman is holding the fish. This is the oldest trick in the book. As close to the camera as possible. And we'll come back to that later in the presentation. It's a beauty right there. And the fish is not too bad either. So let's start with why we do this, why we're monitoring fish. It's important to use this as a tool to monitor changes in the environment, the effects of aquaculture in the big fishing rivers. Do we know the catch rate, and of course to monitor invasive species, but not the least to evaluate the efficiency of a fish weigh. Is it working? And I have to say it's kind of frustrating when people are building fish weighs if they are not measuring them, if they really work. But there are so many different ways to monitor fish, and most of you know these methods. It's the electrofishing, sonars, pitax, videos, and manual count, and they all provide different results. And it's worth noting here that most of these methods require some human resources to make any sense of the data. What we are going to be talking about and what we focus on is automatic quantity monitoring. Main methods there are optical scanning, motion detection videos, resistivity counting, and some combination of the above. So to begin with, I'm gonna play a video for you. Now, here we have a fish pass, a dam, and you can probably see a fish moving up this fish ladder. And as he goes through, he's scanned and get the picture, he's counted. In a bypass, we have there the Elver Watcher, we have the Eel Ladders, and in another bypass, we have a smolt watcher for down migrating smolts. They all send the data out to the data cloud, where users can access it. Also works in pretty turbid waters. And we have a monitor dashboard. The pit tag rear watcher is quite interesting because if the same enters twice, we can see the growth rate. We measure the size, and we've seen this a couple of times with our rear watchers. And I'll talk about each and every product in a while. It's just to give you a quick overview. And I'll start with this one, which is the Rear Watcher S, where S stands for scanner. This is a Rear Watcher that's typically installed in fish ladders or pools, traps, or somewhere where the fish has to pass. And it consists of two scanner plates, which are 20 by 60 centimeters inside the frame. And the width or the distance between those can vary, but it will based on the water clarity each time we can set the distance. But the most common setup and the custom the way we usually set it up is 45 centimeters apart. It seems to be a sweet spot used in many rivers with good success. So this is what happens. This is how it works. We have the two sets of plates. One of them is a sender and one of them is a receiver. And they send infrared beams with two sets of diodes. This is what happens when a fish swims through. It blocks those beams and casts a shadow on the other side. We showed 50 beams per second. That generates a picture of the subject when it's coming through. Gives us a silhouette. Now it's not anything like a video, but a fish passing at an even speed gives us a good image. Well, I won't say a perfect image, but we can definitely tell it's a fish. Can maybe tell it's a salmonid. It's not always that good, but if it's passing slowly at an even speed, we get a good picture. If it goes really fast, it takes on like a torpedo-shaped picture, and if it goes very slow, it gets a bit more distorted. Now, this counter was designed for adult fish, so it can easily handle the biggest fish, but it has some limitations when it comes to the smallest, and usually we don't detect fish smaller than 15 centimeters with this technology. If we try to go much lower, it tends to get too sensitive and pick up debris and air bubbles and what have you, creating false counts. So but we have other methods to count the smallest ones. I will talk about it in a second. This just to show you different silhouettes for different types of fish, not only fish. And if you pay attention to the picture on the bottom left there, if there's turbidity within the scanner, it can create false counts where the air bubbles take on shapes that mimic behavior of an object passing through. We have some ways of just eliminating those events, but it can create a problem. So we would rather have this particular rewatcher installed in a calm area to get best results. And if the fish is overlapping as it comes through, the computer will pick it up as one strange fish. But we can correct this as we go through the data, and I will show you that in a minute. And yeah, not only fish, it's different things. Here we can see how we calculate the size of the fish, and interestingly, the length of the fish is not the best way to calculate the length of the fish. It has to do with the fact that sometimes the fish is bending. It can make a turn inside the scanner, especially if it's going downstream. But the height of the fish is always a constant. So we calculate from that point, and we use the length to height ratio. The ratio generically is set to 5, but you can change that. Of course, if you have different species, you want to have different ratios, and we know some users have been very accurate with this. So they might have salmons in one river that uses like 5.5, but in the next river they might use 4.7, just to get best results for those fish. And we measure from the highest point or the thickest point of the fish. Just to show you how different ratios will affect the size measurement. So it's important to get that right. Then we go to the rewatcher C, and C stands for camera, and this is a camera-only rewatcher. We've used cameras for many years, but this is the first rewatcher that has a camera which is this only source of data. So we use motion detection technology, and we also use more advanced technology to analyze the pictures and estimate the size of the object that is passing through. And so the camera does pretty much everything like the scanner in the previous version I discussed. However, it's worth noting that this particular system works best in very clear waters. So if you have turbid waters, it might not be the best option, but installing this version gives you an opportunity to add the scanners later on if that seems to give better results. So it has to do with the fact that the infrared beams from the scanner, they seem to penetrate water a lot better than white light used for the cameras. Just to give you an example, the cameras are not very effective in turbidity levels above 20 NTU, but the scanners work up to 90 NTU. So that brings us to the rewatcher SC, which stands for scanner and camera, combining both technologies to give best possible results. And there you have the scanner and this tunnel with lights. And the first versions we just had the camera like on an arm, and the fish would not always line up for the best camera angle. They could go down into the pool or to the side, but we came up with this tunnel with lights, and it gave us good results. And another thing that we did there is, as you can see, the camera needs to be pulled back a little bit to get the good whole picture of the fish. But that also meant that we were shooting through a lot of water before we reached the fish. We came up with this air-filled chamber, which is unique, and that means that we can shoot through air until we reach a glass wall. We try to get the fish as close to the glass wall as possible to get best results. Typically, the rear watcher is set up like this. You put the tunnel into the water, and then you will have a cable running up to the computer that we also provide, and hook that up to mains and connect it to the internet, and you're good to go. If you don't have access to electricity, we can run it off batteries and use solar panels. It will need to be estimated for each site, of course, the conditions and weather and what have you. The power requirement there is maybe 30 watts continuous. We can also use a combination of those two and have only the tunnel run off batteries. It takes then about 10 volts and have a wireless link over to the other bank or wherever you have access to electricity and internet in the line of sight. Max 10K. Now, I told that we need to guide the fish through. We need to place the scanner somewhere the fish has to come through, but sometimes it's not possible to narrow it down like that. So we came up with this option. We used that in a couple of sites, just stack the scanners together to cover a wide area. And there's really no physical limitation to the height of the scanners, but as I mentioned before, the distance between them is somewhat limited to the water clarity. So there we have on the upper left system in Germany in Koblenz, where we have a double height scanner. We provide the rear watcher in a plastic cabin with a touchscreen computer. And usually where we install those systems, the local people, stakeholders, fishermen are very happy with the equipment. They know what it does and you know, respect it. But sometimes we would have problems with vandalism, and then we need to make some arrangements. And this one on the upper right there is in California. Now they don't have much problem with vandalism, but the locals like to practice shooting the system, so they had to come up with a safe. Couple of installations around the world. This is a structure that was made in a river where there's no fish ladder or no way of installing anything permanent. So they came up with these floating bars that they attach to the bottom, and the fish has to come up and find the gap on its way, and that's where we put the rear watcher. Here's an installation in Iceland. One of our guys see concrete blocks there used to guide the fish through the scanner, and here you can see the grids in scale to guide the fish into the scanner. And the one there on the right, that's Larinia type fish pass in a tidal area. This is in Wales, in Cardiff Bay. And you just take the scanners and place them against each other there at this fish pass, and it works very well. A couple of more, you can see more examples on our website, rearwatcher.is. Very minimalistic approach there. This is in Poland, and this is a big river in South Korea where we have rear watcher. Now, if you remember the first picture that I showed of the fisherman holding the fish close to the lens, now we're coming back to that. We have the pit tag rear watcher. If you have tagged a fish, it might be a good idea to have the pit tag option. We have worked on this for some years with Biomark, which is now our sister company, and we place a shielded antenna on one end of the tunnel. So usually when you're using this technology, you would like to pick up as broad area as possible, but with the shielded antenna, we just want to pick up the fish as it comes through, because we want to have the measurement of that particular individual. And we saw this fish coming through in Sweden first time in June, and then it came back in August. You can see from the picture it's got a lot bigger, but the picture is a bit misleading because on the right picture he's much closer to the glass wall, but the infrared scanner is measuring him correctly. So it was just a couple of few centimeters bigger, but a lot fatter. As Martin said, we have a range of options, some of them coming from our aquaculture side. So if you're monitoring smolts in a bypass, this could be an option, or this one, which is the smolt watcher pipeline counter. You can count them in a bypass tube with a scanner that's similar to the ones that we talked about in the first version. And then we have, of course, the eel elver watcher, or rear watcher. E stands for eel, and Martin showed you this type, and it's correct. It's the same technology that we've been using successfully in fish farming for many years, and this is great to monitor the elvers.
Magnus, I've got a question for you.
Yeah.
Have you ever recorded any silver eels using the counters, any counters in Iceland or anywhere else?
Yes, we've counted eels with the counter. So they are successfully counted if they go through the rear watcher.
The full silver eels, the adults, yeah?
Yeah, I'll show you an example of that just in a moment.
Excellent.
I'll talk about now the automatic results. This is a rear watcher daily, which takes the data directly from the rear watcher and presents it without any handling. So this is the landing page, and here we have a page for Skipo Castle in Scotland. You can choose a picture of your liking and the text, and it shows the migration period, and the yellow line shows the temperature of the water, and it automatically updates the last fish seen and the largest fish, and of course a table of registrations. If we click any particular day, we will get each line there represents one fish in the 24-hour period. You can scroll through them, you get the silhouette like I showed before, and the video clip of that particular fish. Then it also generates an automatic report, a couple of more charts. You can see the 24-hour distribution. This is for a river in Norway. We can see the activity is there in the afternoon and early evening. A couple of more charts. It automatically groups the fish in size groups, which we just call small, medium, and large. And you can set these groups. And in some rivers where you just maybe have trout, sea trout, and salmon, or char, the size groups will give you a good indication of the species in that river. Now, if you have some years on that river, you can click year comparison, and you can see the fish per day or the accumulated numbers. Really interesting if we have some historic data. Now, if you're a user and you're logged in, you log into this workbench mode, and there you can do a lot more. You can edit the data, and if you come across a strange picture like we showed when the fish was overlapping, you can see the box on the right. You can click insert fish, and it just automatically generates a new fish for that part of the day. So I have at the same time. And also in the workbench mode, it's worth noting we have a couple more charts, and you can set alarms. So if a user set these alarms, or we can do that with them. For example, if you don't receive any data for some period, a local person might be noted. So you have to check on the equipment, or a biologist researching this particular river might also be noted if there's some unusual measurements, unusually many or unusually few. You can also set these alarms. If something is wrong, something is off, something is unusual, you'll get noted. I talked about the accuracy before, so if the ratio is correct, it will measure with 95% accuracy and counts in good conditions with 98% accuracy. It's always good to have references. This is from a user in the US, Ryan Greathouse, and he said, comparing the river watcher with other counting methods he's been using, it's good to have it automated, and it reduces human error. And they used just a viewing class where somebody was sitting and trying to count, but they also used cameras. So the person needed to evaluate and validate the counts, watching a lot of videos. It took a lot of time, and there were some errors involved. It's also worth noting that we had an article published, or not we, it was somebody else. It was an independent research company in Canada that did this for the Scottish Marine and Freshwater Science, and they were comparing different counting methods. It was interesting for us to see how we compare, and it gives us a good idea of how it works in a lot of different scenarios. We scored pretty high, and we're happy with the results. Only instances where we didn't score high was where it was like physically not possible to install the river watcher. Usually when we get inquiries about our products, people will ask how it works and ask about the cost, and then it's just the installation cost or the capital cost. They used a criteria of different things, and looked at structure cost, operational cost, validation cost, counting cost, and the cost summary. And it's important because when we looked, for example, this is in River Ness, we came up on top there. You can see some different methods being evaluated. And the last one there on the bottom is a video system, just a simple video system with surveillance type software. So it was the cheapest by far, actually. And when you look at the capital cost only, but it's down to the bottom if you're looking at the operational cost. A couple of other rivers here. I won't go into that, but interesting report if you want to compare different methods. Now, there are some known issues that we need to mention. One of them is turbidity, and what we have done to overcome high turbidity is to have the scanners closer and make the gap smaller, and also push the fish as close to the viewing glass as possible. And you see in the bottom right picture, you see a real water in a very dark water. This is glacial water, and we've installed there and counted with very good results. Sometimes you wouldn't get the picture of the fish unless it was just really up to the glass wall, but you will still get a pretty good silhouette. I mentioned this before, when we have overlapping fish or lots of small fish coming through, it can be difficult to see what is happening, and the computer will have some problems with detecting what is there, so you might need to validate, and then we have software that is recording 24/7. It gives you a very easy view, like a timeline view of 24 hours. So if everything is normal, it's just a flat line, you can just ignore. But if something is strange like this, a school of fish, you can just click that particular moment and it brings up the video. So you can add fish like we showed before. I'm going to give you a couple of examples. You put the real water into the water and it sends out the data to the data cloud. Here is a recent installation. This is the largest salmon we saw last year in that river. You can see the shape of the silhouette, and you will know in a moment why it's shaped like this. And I will show you the video. But first, I'd like to mention that if you look at the name of this river, it's called Laugardalsá, and this letter at the end, which is A with the dot on top, this is one letter in Icelandic, but it also means a river. So this letter Á means river. So that's your first Icelandic word right there. So every river in Iceland ends with this letter. So if we check out this fish and you remember the silhouette was a bit strange, it's because he goes very fast. So what's the screen? And don't blink. He comes fast through, and then he slows down. But it gets measured correctly, and we get a nice picture of that fish. Now here's an eel in the same river, and he does exactly what we were talking about before. He makes a turn in the scanner. Hold on. There he is. Now he's come up. He's become an adult, so he wants to go to the party in Sargasso Sea. There he goes and turns. We have a lot of fishermen in this river, but they are not the only ones who are fishing. Good clarity, good pictures, water is clear. We have another one in Vesturdalsá. We can definitely see the different species. And if we had the camera-only system there, it would have no problem measuring and detecting what's going on there. But they have the full system with camera and scanner. We have the period for Langadalsá, and here we can see the green dots are the salmons, and the pink dots is the char, Arctic char. It's a sea run char. We can see the salmon is entering the river earlier, and then we have some distinctive peaks for the char. Another river, Langadalsá, we have a nice silhouette, but a black and white picture of the fish. Now, why do we have that? That's because this fish is migrating in the middle of the night, and we have the lights set up so that's white light during the day, and then we have infrared light during the night. It gives us a nice picture. It's black and white, but it's pretty good quality still. And sometimes you want to have this setting so it's not turning on bright lights for fish migrating in the dark. Now this is a behavior we've seen in a river in Scotland. We have a party of juveniles, no adult in sight. Don't recommend that, of course. And maybe it's because they are hiding from this guy. It's in the same river. The fish escapes, but not this time. This is one we got just a couple of days ago. They are pretty effective predators, these guys. So let me bring my browser back in here. If we see, take a look here at RiverWatcher Daily. Now, I am logged in, so I can see a lot of rivers around the world, but you might notice that there's not much activity, at least not in our part of the world at the moment.
Hi, Magnus. Can I just stop you there for a second? We've had another question. It's again about eels specifically in Iceland. Do you have any data that might be available?
On the eels, no, I don't, but I'm sure the Freshwater Institute has data on them. So they are operating our counters in Iceland and handling the data. So I would be happy to take any specific questions about eels in Iceland and forward it to my contact there, and they can provide some information.
Excellent. Thank you.
Now I'm just for fun gonna click here on one counter in the Isle of Mull, and we see this behavior like we saw before. The last registration 43 minutes ago, and the juveniles are just hanging out there. And if I select another one, I just wanted to show another cool feature. Here we have a river that's being cleaned. Okay, it's close to us. Maybe this one here. Okay, I'll click reports and videos, and this is a function that many fishing clubs like to have. So it automatically updates, it measures the fish, of course, but this is a automatically updated view. We can see the latest fish, and so this is very popular in fishing clubs, having it up on a big screen. The fishermen will sit around and just watch these videos, and as they get ready to go out and fish. And the Real Watcher Daily is also, I mean, it's available. You can see it on your phone or from any computer. We've noticed there's a lot of traffic from fishermen to particular rivers, at least. So yeah, that's it from me at this point. If you have any questions, I'll be very happy to answer them. That sums up my presentation, but yeah, like I say, any questions, I'll be happy to trying to answer them at least.
Excellent. Yeah, no, if you do have any questions, as I said, typed in the question and answers box, that's on your left-hand side. Feel free to type, and Magnus will read them out to me. So thank you for your presentation, Magnus. I thought that was great, very informative. I'd like to just quickly add to the back of that a couple of slides to show how ACE also help with you with your overall project. So of course, the technology that VAKI have available, you still need to be able to install it in a river, choose the right site, make sure that of course the flows are low, and we can help you as ACE with all of that. I'll give you a couple of case studies where we've done that. Here, this one is for the Galloway Fisheries Trust up in the west of Scotland. You can see what we've done is essentially modify a penstock frame to provide the in-scale that Magnus described earlier to mount the VAKI on. So you can see, you can easily, using this hand wheel on the right-hand side, operate the hand wheel, and it will lift the VAKI upwards to a place where you can easily access it. You can service it, clean the inside, because of course every now and again you do need to make sure that algae isn't growing on the glass. So you can do all of that. This one is on as Magnus said, on the west coast on one of the islands in Scotland. It's a great counter because we're seeing smolts going through it as well as the adults going upstream. You can see again, ACE worked with the client here. We helped design the overall structure, which you can see on the right, in order to get the fish to go through the VAKI, and carried out the full installation and everything else. You can see the computer that was installed in the Gillies office there as well. Also hydro schemes. This is the scanner VAKI, so the River Watcher S, and you can see that we fabricated the in-scale to be located in the fish pass on the upstream side of this particular hydro project called Arcraig. One in England, this is in Warrington on the River Mersey. So on the River Mersey, there's the Mersey Gateway, or the new bridge that was being constructed, also started off it's not quite a Rivers Trust, but they call it the Mersey Gateway Trust. So they basically wanted to improve the water quality of the River Mersey. And as part of that scheme, they installed a VAKI. We installed it for them, and at the time we did have some concerns about how would this be maintained. As you can see on the left-hand side, the VAKI on this pool and notch and weir type fish pass, it's quite deep, it's difficult to access, difficult to get hold of. So we did actually work with the client afterwards and say, look, we can offer you a penstock solution. And you can see on the right-hand side with the frame. So once again, it rises and lowers out for easy access, easy cleaning, easy servicing. And then we also finished off with this folding cover to make sure there's a safe walkway over the top of it. It's not always about access. Sometimes there's other challenges. This is the River Tweed, or sorry, the River Ettrick, which is a tributary to the River Tweed for the Tweed Foundation. And in this particular hydro location, we had the HDP Laurinia tile fish pass, which was two 900mm tiles wide. So it was a wide gap that we were installing it on. So a total of 1.8 meters. And we needed to make sure that the fish pass, the equipment would stand up against the flow. And the client also wanted to make sure that we were keeping any weeds or debris out of the counter. So we built these baffles to catch any weeds or debris on, so make sure that the influence on the camera was minimal. As you can see here, we went for 3 scanners, and then the video on the on the right-hand side of the fish pass, or the left, it depends which photo you're looking at, but the wider section where the water was coming through, because we felt the chances of fish migration on that side would be the highest. Here you can see the end result of that particular fish pass. You can see how it was installed. Logs installed the VAKI and flooded it. And the quality of videos that we're getting there, and these are videos that the Tweed Foundation have published on YouTube and on their own website, so you can follow them and see these, but you can see really, really nice quality videos. There's a slight issue with some condensation, which has been resolved, so any new videos or more recent ones, you'll notice is clearer. Otters going through. Some nice fish. And ultimately, this is what it's all about. This is also from the one of the islands on the west coast of Scotland. But as I say, ACE, we have a vision of providing not only flood defence, but also making sure that we've got good migration. And this, for me, sums up why we do what we do. You know, it's getting the adult fish upstream. It's part of the whole circle of life. Getting the fish upstream, making sure the smolts can come back downstream. And yes, not everybody's fan of the otter, but it's part of the whole ecosystem. What's the point in having all of the fish and things like that if the rest of the ecosystem isn't there to enjoy it, live on it, however you want to see it? It's really important to us that we help with this circle of life. Installation and turnkey services, as I just explained, we can help you with all sorts of things, from fish passes. There is a previous webinar. If you want the recording, let me know. You can contact us on info@aquaticcontrol.co.uk or myself at martin@aquaticcontrol.co.uk. And I can give you links to any of the previous webinars, for example, the fish migration solutions one that we did previously. And also, of course, we've got multiple other offerings, from fish-friendly pumps, fish passes, such as the fish siphon, Laurinia tiles, eel passes, and of course, fish-friendly flat valves too. So this is your last chance to ask Magnus or I any questions. If you do, please type now and let us know. Did you enjoy that, Magnus?
Yeah, absolutely. Thanks, Martin. It's been fun.
Yeah,
being with you this morning, talking about my favorite things.
Yeah,
is monitoring. If you have any, if something comes up after this session and you have any questions for me, just feel free to reach out to me on email or give me a call, and or contact Martin. You can direct it to me if it's anything I need to answer. But if not, thanks for being with us this morning. Thanks, Martin, for having me.
Yeah, and thanks all those who attended. I don't think we've got any more questions, so we'll leave it there. Thanks for your time, Magnus.
All right. Take care. Bye.